I will come and talk about what happens next year, what courses we have, what options are there for you to consider. So we have 3 lectures as normal this week. Assignment about Java, optional assignment is due next week on Tuesday, and is about using Java, as I mentioned before. There is no tutorial this week. So here we are. Any questions?
On the optional assignment, there are 2 questions I had. One, do we actually need to state the overrides like in the Java, because it works without me putting at override? Do you want
It would be preferable.
Yeah.
It's give you good practice, so you can put override.
And in the methods with the C++, there are a bunch of constant reference. Do you want us to use constants?
You can't.
Bothered. You can't. Okay.
There is no.
Sure.
You can't.
There's
Java
no
doesn't have that. So you use them just as references
Yeah.
if necessary. If you are passing by value, you use pass by value. Because for native types, you don't have references in Java. Yeah. Any other questions? So, we have started looking at generics last time, and we looked first at the library, and we have seen the collection. Remember, there are 3 groups: interfaces, abstract classes, and concrete classes, and they work together to provide facilities we have seen in C++ as well, mostly about containers. Collections refer to static algorithms which provide a similar functionality as algorithms in standard template library. But we will have a look today, and you will see the approach is a little bit different, how to use them. And then we will have to look at how to write our own generic types using Java. And in particular, when we have to use comparison, because we have no operator overloading in Java, you will see that you have to implement a method. So we have seen that when working with generic types, Java provides a relatively simple setting to give us access to containers like array list, and we talked about the difference between a little bit vectors and array list. And between these concrete types, most important for us would be array list, probably. We have a lot of examples, and less examples from the other groups. And you will see that frequently we have array list objects defined from list type in order to allow for polymorphism. List is a base class, is an abstract class, and array list, this is it's an interface, and this is a abstract class, the one. But array lists are constructed from list, and then we can use polymorphism. We can define array list just from array list objects. you don't have to go from the list type, but it's there to show you that it's possible. Okay, we will come back to this when we look at example. So collection refers to containers, collections refers to algorithm. This is the main thing. And these algorithms are implemented as static methods, so you have to call the class with the method name. And they provide similar things like in C++. Therefore, here we go and have a look at some common algorithm. Interesting to note is that some algorithms work on any class based on a parameter collection, but some other algorithms require specific type of collection. Reversing, shuffling work only on list, or any one who is derived from list, or implements list more precisely. If we look at this example, we import list, array list, collection, just to have access to these tools. Notice that we define A1 of list type, but it's an interface, as I said, but we initialize it with an array list because you can't create new list object. Interfaces, no. You can put here just array list, it's okay. But this is to let you know that you might want to create list in order to allow for objects of this type, maybe create something which has the list interface as a parent. Work not only with array list, but work with vectors as well. So you might want to add vector objects if necessary. And then you can see we construct the objects in our array list. And then we can invoke one of the methods, static method, binary search, static method invoked on the class. And we are looking for element 10 in this collection. Normally, what you can do is, if that element is there, you can print where it's found. And notice that all counting starts with 0, 1, 2, 3. You get the value 3 out. When something is not found, like here, 15 is not in that collection, you get an output which is a negative value. And the way Java has decided to handle this is, okay, if 15 would be here, would be between these two, right? So it might be on the 4th place, 0, 1, 2, 3, 4. It should have been, if it would have been here. Subtract 1 just to make sure that there are no confusion, and we get -5. This is displayed. And it's interesting to know why you have to subtract -1. Why not return the negative value as it was? Any? What about for 0? If the element would have been in 0, negative of 0, it's 0. So you look for something which should have, is not in the collection, but is the first element. So its index should have been 0. Just negating, it gives you 0. So it gives you a false answer. It's there and it's the first element, which is not correct. We are talking about element not found. But if you add -1, 0, -1 gives you -1. It's clear it's not there. Right. So I mentioned some methods require to be derived from specific containers like that list. But others can be applied to any type of object. They are general things. Now, before 1.5, generics were not supported, and when they were introduced, they were not introduced with a lot of thinking, and it had to be updated with the latest version. Java 7 had improved things. So, because everything is derived from objects, they did not consider necessary to specify the type, because in the end you can have everything available, because it was in the end an object type. But this leads to problem. For example, you can have this list where you don't have any specification of the type. Notice? And then you add some integers. What is the problem here? If you want to recover an element from the list, you have to know what was the type and specify it here, because the type was lost. Okay, list get I. The way Java works with types, after it does syntax checking, it erases a type. It ignores a type. And this erasing means the type is not there any longer. The compiler does not have access to the type. And that's why you have to put yourself the type. And this was considered error-prone, cluttering code, not very good. And you are allowed to do this stuff because your list can be of any type. And if it's an integer, okay, it's an object type. So here the type in the end was an object, and an object is every of these can be an object, an integer or a string. So you are allowed to combine them like this. That's why it was required to have this integer. The way to work with such lists were, okay, after you get the value, you check, is this an integer? If yes, do something. If it's a string, do something else. And this was not the best approach. In particular when writing libraries and people extending types. You don't know what other types. What if I create a student type and I add a student type? Some libraries don't know about my student type. And I have to look, is an instance of student, anyway. So it was changed in Java 7. And we will see that with that change, you can restrict a type, like in C++, when you invoke it. But because of compatibility issues, both approaches work. This one you have seen, it's still there because there is a code base based on that approach. And with Java 7, they have moved to a better specification of type, like here. When you declare an object of a list, you have to specify the type. And this approach, it's clearer. The compiler detects errors. If I want to do this, I am not allowed because of this. So notice the difference. And now I don't have to convert or specify this is an integer. So as soon as I use this syntax, everything is much clearer, easier to use. So you can use list of integer or array list of integer. It's the same. For this example, yeah. And array list here definitely refers to the concrete type and construct our array list. This refers to a interface which is created from a concrete type. And both are okay to use. Now, if you want to write your code using templates, it's much simpler in Java. You don't have type a template keyword. All you have to do in order to create your generic type called entry is specify two parameters, whatever you want to call them, because they specify future type, integer or float or whatever. It's good to capitalize them. So this is first type, second type, you call it whatever you want. I call them for brevity K and V. As you can see, I have a constant data for this class. This is how you have to use constant in your assignment, optional assignment, right? They are private and constant. And then in the constructor, I initialize them. So these entries are stuck with the objects we initialized. And we have getter methods just to maybe display their values. When you construct objects, very simple. It's a reference. You have to specify types, always generic types with capital letters, like here, and then pass values in the constructor, right? What you can do is recover the value. What is the first? The value, the first component. What is the second component? And you can display them and use in some other code. Notice very simple syntax. And in order to create methods which are generic, again, we are not cluttered with template. This notation tells the compiler, Java compiler, that we have a template here. And what the compiler does whenever it encounters array printer here, it substitutes it with a code for us. So it's done at compilation time. And after that, the type integer is erased and just the values are used. Anyway, so notice when we use it, like for methods in C++, we don't have to specify my array printer depends on integer. The compiler knows where the type comes from. Okay. So this part looks very similar to how you use function templates in C++. Implicit specialization, while this is explicit specialization. When you define types, you have to specify. First is a string, and second is an integer. But for the function, when you use it, you don't have to specify. This is for integers. And there is another syntax. Here it's an example how to use template generic programming in Java program. So we have a concrete class. G method does not depend on anything, but inside we have some generic methods, and you can see that that uses this generic type. So this is a class defined with parameters class. They are both in the same file, and here we have one data member and two methods. What is interesting here, we use just this type just to declare two objects, G1, which will be based on a string type. Notice how the constructor can be called with no parameters here. So we call the constructor of this type, you have to put it with empty brackets. You can put string if you want, but it's not necessary, and you call the constructor, which is implicitly defined there. And then we set the values for these two objects. Now, we have defined it's equal, a method which tests for equality of content of our values. Notice, J1 get the value and compare with the value from J2. If they are equal, return true, otherwise return false. This equals is coming from the object class. Okay. Now, as you can see here, our Boolean value calls that method we have defined with these two arguments. And it looks at contents, finds that the contents are equal, and we get true when we display they are equal is true. Now, if we look at test of equality with a equal symbol, remember this looks at the pointers. Are these objects stored in the same location? The answer is no, because we have asked for memory with this. So we have here a memory location. We have here another memory location. So with this equals, we are testing for pointer equality, and the answer is false. As pointers, we don't have equal references. And I mentioned this before, symbol equality does location equality, while equals refers to content equality. So now you know there are two types of equality in computing. Anyway, important to use always integer, float, character. So the class types, not the primitive types when working with numbers. And then many algorithms provided in collections need to compare elements. How to do sorting, how to check that one element is there or not. And in order to provide comparison, we have to implement some compare method which is provided in the comparator interface to allow for comparison. And this comparison has to be total. It means if A is greater than B and B is greater than C, you should have A greater than C. Otherwise, division is not total. A can divide B, it is an operator which is not total, but I have to think about anyway. So let's look at an example. How to design your comparable types. We have the circle type, which we assume we have defined somewhere, and we have to define a class, circle comparator, which has to implement this is the interface, and you have to specify for what type, for our circle type. And all we do here, we implement a method called compare, which is taking two circles, as you can see, and then look at their radiuses. And if this has radius smaller than the other, returns -1. If they are equals, returns 0, otherwise returns 1. So we, at this moment, can compare two circle objects. How we do it? We construct a list initialized from an array list of circles, circles here, and then we call the constructors to give some values to the radiuses. Then, with the get method, we can display the values which were stored in our list for the radius for each circle, and we will get some numbers between 0 and 7, because I times 10 modulus 7, you always get the remainders, and this remainder is a number between 0 and 6 included 6. So some of the numbers will repeat here, definitely. After that, we invoke the sort algorithm. Notice collections.sort, which is static method of the sort, and we invoke our algorithm on that object. We have to specify how to compare. And to specify how to compare the elements in the list, you have to pass a reference to your comparator class. And with that, so for every sorting, you will have 2 arguments for your invocation if you are working with user-defined classes like here, circle. For library classes, there are default comparators. We don't need to worry. And then we display again, and we will get the radiuses in increasing order. So, as you can see, everything is a little bit more complex in terms of writing when you have to use method instead of symbols. Remember, collection is an interface from which we have some representation, list set queues, and then we have concrete classes. You have generics method in Java available. The library doesn't use this as much as C++ standard template library, but there are usage of template. If you ever want to learn a little bit more about all these facilities, be aware the best way is to go to the YouTube and look at Oracle learning channels, and they have zillions of video clips. One is for Java learning, and it's a nice way to find information. about Java. And this concludes our discussion about this object-oriented language. So, there are things we didn't even touch. Java doc and software to generate documentation in HTML format if you put your comments in a specific way. So you have to this comes with SDK, Standard Development Kit. We didn't talk about annotation. We didn't talk about automating testing. JUnit is a testing framework to provide testing. As soon as you design a class, it's recommended to have a program which does testing for your classes even before you start coding. And JUnit was one of the first automated testing which came into place. Now they try to design something for C++ as well, for other programming language, but this is all we have to look about. We stop here, we don't need to go through these things, and we still have time. So, slideshow from beginning. We have covered the object-oriented approach in C++ and Java, but we have looked at this with simple examples, so be aware. Maybe you remember at the beginning we said Java and most C++ object-oriented programming languages are there to solve huge problems. In general, you will have something like 20 classes working together, 100 classes sometimes working together, so for big problems. And people discovered that in this, how many years? 30 years since Java and C++ are around, there are some recurring problems which at the scale of large programs, very large programs, can be solved following some recommendation coming from people who encounter those problems when they try to construct libraries, when they try to construct operating systems. They encounter those problems many times, and at some stage they said, okay, what is the solution we can do? And they come with something which is not an algorithm, a set of, they are not algorithms, they are not code examples, they are recommendation for possible approaches to solve the problem in an efficient way. You don't have to use these design patterns now. Probably you have to practice and work with C++ or Java or any other object-oriented programming language for a while before you will go into some details. But from people who are working on a daily basis with large, complex C++ or other object-oriented programming languages, they said that this list of algorithms or design patterns help them a lot to produce better code in a faster time. Anyway, this design pattern listing came into being with this book, Elements of Reusable Object-Oriented Software, and it had 4 authors. That's why you will hear the book by Dengo 4. GO4, Gang of Four, and appeared in 2014. There are some video clips. If we have time, we will look at one of them, hopefully. But a short explanation, maybe more than I will cover, is in Wikibooks, and you will see here they have C++ code examples for most of the patterns. A more detailed explanation is in this site, where they provide code examples in C++, in Java, and in Python, and in C#. They for the same pattern. So there are many things about this. They were good because it avoids effort duplication. Once again, it's not a code solution, it's not an algorithm, it's a recommendation for solution to common problems which you might encounter sometime. Is a description of a particular method of solving a problem. There is one question in the final exam, and it refers to patterns, and it says a design pattern is a code, is an algorithm, or is true or false. And it's not code, it's not algorithm. It's a description of a method to solve a problem. And it's not mathematically proved that it's a best solution. Like many things in programming, you don't have mathematical proofs, which is ideal, but is experimental proof. Other people found it useful. Right. There are 23 classical design patterns, but they have added more, and now there are something like 45. We stick with this classical one, and they are grouped in these three groups. Some groups refer to how to create objects from existing objects, builder, factoring, they have fancy names. Structural, how to organize your objects in a class. It's not as simple as it looks. And behavior, how objects communicate to each other. Iterator, for example, is a behavior pattern. And if you think back, we have iterators in C++, in Java, and that behavior, which a very brief glimpse that you have had it into with your assignment, showed you that there is some features which probably it's not so obvious if you haven't used it. Okay. Creational patterns are coming in, these are the 5 creational ones. How to use abstraction. In large problems, you have to have a base class or some interfaces which are abstract in order to obtain a solution which is efficient and in particular extendable. That's the problem. Anyway, so we will look at singleton, and you will see that with no knowledge about this, you wouldn't have been able to come up with that solution yourself. So there are more structural. Composite refers to having data of other classes as objects in your class. Composite means composition, use composition. So this is a pattern which can be quite general. There is a nice side there. And then behavior patterns. And I mentioned iterator. Template method, so having some general behavior inside a class. The behavior is the most complex case you might have when you design large systems, how classes interact. It's very complex. Now, patterns are general frameworks which is used to base your solution on these frameworks, hopefully. They are general and they can be implemented because of their generality in Java, in C++, in Python. So it's not a code given, but a general approach. Why it's good, maybe after you become a little bit more used to C++ and other object-oriented programming, to go into finding more about design pattern. It avoids time wasting and come up with better solution. Plus, if you write in your code, you have used iterator pattern, other programmers can understand your code much quicker because it's a common language somehow. Singleton is a design pattern which is very easy to understand somehow, and that's why, because of its simplicity, we will look into some examples. So this program requires the use of, you might want to have a type, but you want only one object of that type, no more than that. Some example, if you are dealing with dates and you have a calendar object, you might share your calendar with your family, but you want that single calendar objects, and your relatives can add dates, events in that calendar. But this is relying on the information that you have one calendar object which is used by you, is used by to add events, is used by your brother, sister, whatever, wife, kids. So it's important to have only one object. Another example of password is some example of where you want a single password object to be used when you log into, I don't know, your LinkedIn or Facebook. So this is the representation of what would be required as a minimum to a singleton. The constructor is made private to disallow construction of many objects at the same time. So this keeps the object to one element. And then you have some methods, which are public, as you can see. For a calendar, you want to display events, display month, display whatever. So you can have various methods. But in order to keep your set of objects to a single one, you will see that the task is performed inside this method, getInstance. The idea is to hide the class constructor, and we have seen what does it mean. And what we will put in code is when the method getInstance is called, it creates one and only one object of this type and returns it. Every other time when someone tries to create a new object, the getInstance will return the existing one. So, assume that we have this setting for a class calendar. It's a Java example. The constructor for the class is private, right? We have here private static method. And as you can see in getInstance, if we are at the beginning, no object was created, we create one. If this is invoked when we have already an object created, we return that object which was created. So as you can see, this method allows only for one object to exist of this type. You have to think about it. And then you might have some other methods here. But if you think back, probably you realize this is not something you might come up with, a solution like that. People came with that after some experimentation. So here is how we use our type. We have a class example called, and this is the entry point. We construct a calendar from getInstance. The constructor C2 getInstance is called again and some method, whatever. Or this does not create another object. This does not create another object. That getInstance works with the one which was created here. Therefore, we are sure in knowing that only one object exists. Critiqued. Only object-oriented programming languages use design patterns. Functional programming, declarative, logical programming, they don't need it. And because of that, Peter Norvig, which was a very well-known computer scientist, I think he worked with Lisp, said that 16 out of 23 patterns we have seen are included in other languages. So this need for patterns appears because of the way object-oriented works. Do not try to force patterns into your code, because the code can become very cluttered and very complex. So you need to write your programs, and when you see that something it's not so simple, or some pattern repeats, maybe then you have to look into this use of design patterns. And then there are anti-patterns, which try to identify situation where the code is ineffective and high risky situation. As you can see, books about Java, project management, they introduce it in management of software, developing of application. And to give you an example, the simplest anti-pattern is spaghetti code, where there is not much structure. You try to fix something, add a new variable, it works, but then you discover other bugs, add another variable, another method. So there is not enough thinking in the design. Once again, if an object has a lot of method, maybe it's not a good approach. So objects should have relatively short list of what they do and then work together. Code smell. These are not situation, maybe like in C# class, I think you have been told about code smell. It's a solution which works, but with new addition to your code, it can either produce a bottleneck, something which goes much slower than you need, and this indicates a deeper problem. So they are not incorrect, but again, designing on which we normally should spend a lot of time, and we normally don't spend much time. For large problems, it's a requirement, and it is a must, and people spend a lot of time, in particular because large programs are developed by different groups. One way to improve software is refactoring. Be aware, the functionality of the software is not changed, but the code is cleaned up. If you see that something repeats several times, you make it into a function, that is refactoring. You don't change what the program does, but make it clearer, and maybe if you need to change that set of code, you change it just in the function. Reusable, it's interesting, when should I use pattern design? Stack Exchange has good recommendation. Like exceptions, this pattern design shouldn't be used every time. It's good to know about them, use them. After you get a little bit more experience, you should be able to go and read and take time to understand them, see how other people use them in order to improve your code. So with this, we have finished our discussion of new material. From now on, we don't have any new stuff coming. Everything which I covered, it will come in some form or another to haunt you in your future life as a programmer. I hope not. I hope that it's a base to work and use to enlarge your knowledge, because you will have to learn all your life to go in this profession. Thank you very much. So this is the end of lecturing, and tomorrow, no, sorry, Wednesday, we do revision. I put the material up. I have extra bits and pieces to talk about. So Wednesday we have revision and exam preview, and Thursday I will come with some list who is teaching what, and if you have any other questions, please let me know on Wednesday or on Thursday. Thank you very much. See you around, and thank you for coming, because it looks like people are very busy this week. Yeah, thank you.